Have you ever noticed how enemy tanks often explode right after taking the first hit? In such situations, unlike with Western tanks, the chances of survival are extremely low. Here's an example. Two Ukrainian Leopard tanks are advancing down a road when one of them gets targeted and hit. At first glance, it looks grim, but in reality, it's not what it seems. The flames you see are caused by the controlled ignition of the tank's ammunition. Right after that, the entire crew is safely evacuated from the battlefield. The building where the enemy is hiding has already been identified. A Ukrainian Abrams tank receives the coordinates, aims its cannon, and hits the target with a single shot. A second shot brings the entire structure down. In these kinds of assaults, a Bradley usually moves in first, delivering continuous fire to break the enemy's resistance. Then, an Abrams joins in, systematically destroying the enemy's defensive positions. This is what timely support looks like. In a settlement under enemy attack, a Russian tank tries to neutralize Ukrainian forces holding their ground. But the Russian crew fails to notice the Bradley arriving for support and exposes the tank's vulnerable side. Within seconds, the Bradley hits its target and keeps firing as it moves toward nearby buildings. The tank is taken out, Ukrainian troops are extracted, and the enemy is forced to retreat. There's also a brief but decisive clash between an older Bradley and a modern Russian BTR-82A. The Russian BTR spots the Bradley first and opens fire, but the response is immediate. The muzzle flashes show the Bradley returning fire. During the skirmish, the BTR tries to maneuver out of the way, but the outcome remains the same. The duel ends with the Bradley's clear advantage. Next up is Russia's most advanced tank model, the T-90M. Let's see how well it holds up against the realities of modern warfare. When these tanks take damage, it's not uncommon for the ammunition inside to catch fire almost immediately. In one case, a Ukrainian FPV drone approaches an open hatch and detonates right there, igniting the ammo. Flames burst out from the turret and the driver's compartment, leaving yet another T-90M abandoned on the battlefield. The same tactic is tried on another tank. In the footage, you can clearly see flames shooting out from the hatches on the turret, the driver's hatch, and even the barrel. In situations like this, the crew has almost no chance of survival. In another scene, a Russian tank moves in for an attack, but the Ukrainian crew spots it just in time. An FPV drone locks onto the engine section and strikes it. Moments later, a second hit lands on the turret. The damaged tank grinds to a halt, unable to advance any further. Meanwhile, a third drone is already in position. Since the hatches are shut tight, the operator targets the vulnerable spot between the turret and the hull, where the armor is thinner and ammo is stored nearby. The blast pressure forces the hatches open and flames erupt from inside, engulfing the tank within seconds. As the armor heats up, the fire grows even more intense. Now, a strike drone loaded with a hand grenade heads toward its next target. It approaches a modern Russian tank, which at first glance seems well protected. But the drone swoops down and drops the grenade at just the right moment, causing a powerful explosion. Flames shooting out through the openings confirm that the tank's ammo has detonated inside. In another scene, the target is even more heavily fortified. Russian forces have reinforced the tank's turret with wire mesh, added extra armor plates, and installed electronic warfare systems. Despite this, an experienced drone operator manages to drop a grenade right through a small gap left in the hatch. A fire breaks out inside, but the tank's fire suppression system fails to activate. The only reason there isn't a massive explosion this time is that the tank had already used up its ammo. Here's another example. This tank's underside armor plate has been reinforced with chains. The turret is fitted with dynamic armor blocks and extra shields. A mounted machine gun and an electronic warfare system stand ready. Yet the attack drone hovers above, then drops lower for a perfect angle. The grenade is released with pinpoint accuracy. At first, only a faint plume of smoke rises. Then, suddenly, the entire tank bursts into flames. The heated armor plates begin to explode. Thermal decoys ignite and sparks fly in every direction. In moments, the tank is completely disabled. Finally, in the last scene, a tank is seen maneuvering and firing its gun. Everything seems to be going according to plan, until it rolls forward and hits a hidden mine. A blast that would have merely thrown an Abrams or a Leopard off track turns this Russian tank into a fireball. The reason? Extra ammunition stored under the floor that can easily detonate in situations like this. In this scene, we watch another Russian tank advancing across the terrain toward Ukrainian positions. As the tank pushes forward, a Ukrainian drone operator carefully pilots an FPV drone behind it. The drone quietly closes in from the rear and locks onto a precise weak point. With a well-executed maneuver, it strikes the target dead on, triggering a powerful explosion. Flames shoot up from the top of the tank, showing that the ammunition inside has detonated instantly. For the crew, the chance of surviving such a blast is almost non-existent. In another shot, we see a Russian tank that's been reinforced with special armor plates. These extra layers appear to be designed specifically to defend against drone strikes. But there's a critical oversight in this setup. The tank's front section has been left unprotected. Spotting this vulnerability, the skilled drone operator directs the drone straight at the exposed area and makes a precise hit. A moment later, the tank erupts into flames, turning into a fireball despite all the added protection. Within seconds, the vehicle is completely disabled and left behind. The ongoing war between Ukraine and Russia has brought the relevance and limitations of tanks in modern warfare back into sharp focus. What began as a clash between two armies that largely relied on Soviet-era armored doctrines and vehicles has turned into a proving ground for how tanks can, or cannot, survive in an age dominated by drones, precision-guided munitions, portable anti-tank weapons, and real-time battlefield intelligence. At the core of both sides' armored forces lie decades-old Soviet tank models such as the T-64, T-72, and T-80. These designs were revolutionary in their time, fast, relatively light compared to Western heavy tanks, and designed to be mass-produced and easy to maintain. After the collapse of the Soviet Union, Ukraine inherited thousands of these vehicles and a significant industrial base capable of repairing, modifying, and even building tanks and spare parts. Russia, meanwhile, retained not only vast numbers of stored vehicles, but also the capacity to modernize them and produce entirely new models. In the years that followed independence, Ukraine's defense industry focused heavily on upgrading its existing fleet, rather than developing completely new tanks. Ukrainian engineers worked on modernization packages that added thermal imaging sights, digital fire control systems, reinforced armor plating, and modern communication equipment. Such upgrades aimed to narrow the gap with more modern vehicles without incurring the immense cost of designing new tanks from scratch. Russia, benefiting from larger defense budgets, pushed forward with modernization programs for its T-72s and T-80s, and introduced the T-90, an evolution of the T-72 platform with improved protection and electronics. The T-90 was touted as the backbone of Russia's new armored forces, and in parallel, the T-14 Armata project emerged, designed to showcase Russia's ambition to field a next-generation main battle tank, featuring an unmanned turret, an isolated armored crew capsule, and cutting-edge active protection systems. However, high costs and production challenges meant that only a handful of T-14s have actually appeared in the conflict. and the vast majority of Russian armor remains based on legacy platforms. When the full-scale invasion began in 2022, many military analysts predicted that Russia's numerical advantage in tanks would quickly overpower Ukrainian defenses. But reality turned out to be far more complex. From the outset, Ukrainian forces leveraged portable Western-supplied anti-tank systems like the Javelin and NLAW with devastating effect. Combined with well-prepared ambushes, effective use of terrain, and the extensive deployment of small drones for reconnaissance and kamikaze attacks, Ukrainian units demonstrated how tanks, no matter how numerous, could be highly vulnerable when deployed without sufficient infantry cover, air defense, and electronic warfare support. One of the defining images of the war has been long convoys of Russian armored vehicles stalled on roads, immobilized by destroyed bridges, ambushes, or logistical failures. Many tanks were knocked out not in large-scale tank battles, once typical of Cold War scenarios, but by small teams hiding in forests or urban ruins, using drones to spot targets and guide precision strikes. Some tanks were disabled by simple tactics like placing mines or improvised explosive devices along likely routes, then targeting immobilized vehicles with direct hits to their weakest spots. A critical vulnerability has been the upper armor of tanks. Modern anti-tank weapons and drones frequently strike from above, where the armor is thinnest. In response, Russian crews began improvising cope cages, metal grids welded on top of turrets to deflect drone-dropped munitions. While sometimes effective against simple attacks, these makeshift solutions often failed to stop more sophisticated strikes and occasionally added extra weight or obstructed turrets, creating new operational headaches. Ukraine, meanwhile, gradually integrated modern Western tanks like the German Leopard 2 and the British Challenger 2 into its forces. These vehicles offered superior armor, advanced targeting systems, and crew protection compared to legacy Soviet models. On open terrain, Leopard 2s have performed well, delivering accurate firepower and withstanding hits that would destroy older tanks. But they also revealed logistical challenges. Spare parts had to be sourced from multiple countries, maintenance crews had to be trained on unfamiliar systems, and supply lines had to reach deep into active combat zones under constant threat from Russian drones and missile strikes. Maintenance and repair have been decisive factors. Ukraine has made creative use of mobile repair teams and small frontline workshops, sometimes restoring heavily damaged tanks to working condition in days. This rapid turnaround has helped maintain fighting strength despite losses. Russia, in turn, relies on its large-scale repair depots and the ability to reactivate older tanks like the T-62 and even T-55 from long-term storage. While far less capable than modern tanks, these older models can still be used in roles